Good morning, dear students. Welcome to Learn with Chaitra. Our today's concept is the solution. The solution chapter, it is in 11th and the 12th standard. Okay, what is solution? A solution is a homogeneous mixture of two or more substances. What are those two or more substances? A solution is a mixture of a solute and a solvent. The solute is the substance that dissolves in a solvent. The solvent is the substance that does the dissolving, and the solvent is usually present in greater quantity than the solute. The particles in a solution are evenly distributed. The solutions can be solids, liquids, or gases. Okay. In objectives that are present in this chapter, they describe the formation of different types of the solutions, express the concentration of a solution in different units, state and explain Henry's law and Rolle's law, distinguish between the ideal and the non-ideal solutions, explain the deviation of real solutions from the honest law, describe the qualitative properties of the solutions and correlate this with the molar masses of the solutions. Explain the abnormal qualitative properties exhibited by some solutes in the solutions. The types of the solutions, what are those types? The three types: gaseous solutions, liquid solutions, and the solid solutions. Homogeneous mixture of two or more than two components. What is homogeneous mixture? A homogeneous mixture is a mixture where there is a gradients are blended so well they cannot be separated out. The components of the homogeneous mixture are evenly distributed throughout and have the same properties. The example of the homogeneous mixtures are the salt water. The salt water, the salt is dissolved in water. And air, it contains the mixture of gases, mainly nitrogen and the oxygen. And in coffee, they brewed without any solid particles. And the sugar dissolved in water, a uniform mixture of sugar and the water, and vinegar, a mixture of citric acid and the water, and the steel, alloy of iron and the carbon. These are the example of the homogeneous mixture. What about heterogeneous mixture? What is the distinction between the homogeneous and the heterogeneous? And the homogeneous versus the heterogeneous mixtures. A heterogeneous mixture is a mixture where the composition is not uniform throughout. The component of a heterogeneous mixture can be visually distinguished. How to separate the homogeneous mixture? We can separate it by some methods, technical methods, by some mechanical process. The homogeneous mixture can only be separated by mechanical process such as heat or using fan filters. The thermoplastics, the polymer that heat and cool evenly into solid plastic solids, and the brass, alloy of copper and the zinc, and the steel, an alloy of iron and the carbon. These are the examples for the homogeneous mixture. Okay. One or more components present in the solution other than the solvent are called solute. The component that is present in the largest quantity is the solvent. The smallest quantity is a solute. In this unit, we shall consider only binary solution. What is binary solution? In this chapter, we consider only the binary solutions. Before that, you should know that the binary solution definition. The binary solution is a mixture of two substances or components that are completely miscible. The meaning is they can mix together in any proportion. I will give you some explanation. One component is present in larger quantity than the other and is called the solvent. The other component is present in a smaller quantity and is called the solute. I will give you some example for the binary solutions. Example, ethanol and the water. A common binary solution found in the alcoholic beverages. The concentration of the ethanol determines the strength of the drink. And the next example is the salt and water. The salt dissolves in water and making water, the solvent and the salt, the solute. The sugar and water. The sugar crystals change the state from solid to liquid when dissolved in the water. These are the examples for the binary solution. Next, we will move to the types of the solution. We know that I told you the gaseous solutions, the liquid solution, and the solid solution. These are the types. The solute in gaseous solution, the solutes are oxygen and the nitrogen gases. The solute is liquid, the solvent is gas, the chloroform mixed in nitrogen gas. In liquid solution, the solutes are gas dissolved in water. In liquid in liquid, example, the solute is the liquid and the solvent is the liquid. The ethanol dissolved in water. And here, in solute part, in liquid solutions, the solid is a solute and the solvent is the liquid. So the glucose dissolved in water. The third type is the solid solutions. The solute is the gas and the solvent is the solid. So the common example is the solution of hydrogen in palladium. Here in solid solutions, the solute is liquid and the solvent is a solid amalgam of mercury with sodium. And in solid solutions, solute is the solid and the solvent is the solid and the copper dissolved in gold. The last one in gaseous solution, the solute is gas and the solvent is gas. The mixture of the solute is solid and the solvent is gas. The copper is in nitrogen gas. These are the example for the gaseous solutions, the liquid solution, and the solid solutions. The examples of the solution, I already gave you some examples. The sugar water, steel, salt water, the pancake syrup, the natural gas. These are the examples. Parts of the solution. A solution is made up of solvent and the solutes. A large amount of in a solution, the substance lesser than amounts is the solutes. Larger amount is the solvent, and the small lesser amount is the solutes. Here, the solvent is reacts with the solute, we get solution. Expressing the concentration of the solution. The composition of the solution can be described by expressing its concentration. The latter can be expressed either quantitatively or qualitatively. There are several ways which can be described the concentration of the solution quantitatively. Example, first one, the mass percentage. The mass percentage, the mass of the percentage of the component of a solution is defined as the mass of a component equals the mass of the component in a solution divided by the total mass of the solution into 100. This is the empirical formula. Example, if a solution is described by 10% of the glucose in a water by mass, means that the 10 gram of glucose is dissolved in 90 gram of the water, resulting in a 100 gram solution. The second one is volume percentage. The volume percentage of the component equals to volume of the component, the total volume of the solution into 100. Example, the 10% ethanol solution in water means the 10 ml of ethanol is dissolved in water such that the total volume of the solution is 100 ml. Next one, the mass by volume percentage. It is the mass of the solute dissolved in 100 ml of the solution. The parts per million. The parts per million equals to the number of parts of the component divided by the total number of parts of all the components of the solution into 100. The next one is the mole fraction. The mole fraction of the component equals to the number of moles of the component divided by total number of moles of all the components. Example, in a binary mixture, if the number of moles A and B are Na and Nb respectively, the mole of fraction A will be Xa equals to Na divided by Na plus Nb. This is the formula. Okay, next one is the problem. Calculate the mole fraction of the ethylene glycol C2H6O2 in a solution containing the 20% of C2H6O2 by mass. Here they are given 20% by mass of C2H6O2. Here the equation is C6H6O2 equals to N into C6O2 divided by N into C2H6O2 plus NH2O. This is the equation number 1. The mass of C2H6O2 is they are given already 20 gram. 20 gram. They are already 20%. Here they are given. Here they are given 20%. So it 20 gram. The mass of the water is 100 minus 20 equals to 80 gram. The 20%, the 20% means they are given 20 gram. So mass of the water is 100 minus 20 equal to 80 gram. Here, which one is the solute and which one is the solvent? The solvent is the water and the solute here C2H6O2. Finally, it becomes the solution of C2H ethylene glycol. The molar mass of the water H2O, the chemical formula of the water. So 1 into 2, 1 molecule of hydrogen into 2. 1 into 2 plus oxygen. The mass number is 16. So the mass number of hydrogen is 1. 1 into 2 plus 16 is equal to 18 gram per mole. The molar mass of the ethylene glycol chemical formula C2H6O2. Carbon, the mass number is 12. 12 into 2 plus 1 into 6 plus oxygen is 16. 16 into 2 equals to 62 gram per mole. The moles equals to given mass divided by molar mass. The given mass is 20. They are given already. Okay. And the molar mass 62. Here it is there. Okay. It is 62. So 20 divided by 62 and C2H6O2 equals to 0.322 mole. So here the moles of the H2O equals to 80 divided by 18. Here the given mass is 80. Here it is there. And its molar mass is 18. So 80 divided by 18 equals to 4.44 mole. And value substitute for equation number 1. Here we have to apply these values. One formula, the number of moles of the component divided by total number of moles of all the component. So the number of moles of the component is 0.322. Here it is there. The total number of the component is 0.322 plus 4.44. So the final answer is 0.068. 0.068 is the mole fraction of the ethylene glycol. Mole fraction of C2H6O2 means ethylene glycol is 0.068. Okay, thank you. Next class we will solve the molarity of a solution.